Electrostatics. Let me commence with Coulomb's law. What is Coulomb's law? The Coulomb's law is this equation. F stands for electrostatic force experienced between the two charges Q1 and Q2 separated at a distance of r, where K stands for Coulomb's constant, and it is given mathematically as well. K equals 1 by 4 pi epsilon naught. This stands for permittivity for the free space. If you take epsilon, it becomes a permittivity for the any medium exists between the two charges. The value of K for the free space is this. It is in SI units. 9 into 10 to the power of 9 Newton square meter per square coulomb in SI unit, the value. This value must be known to solve the problem. There are 5 problems. 1, 2, 3, 4, 5. The problems are not written. The data of the problem is taken. The data of the problem. I will read the problem. The problem for which the data is given. The first problem, just looking at this also you can read it. There are two charges Q1 and Q2 in the space, whose magnitude is given, and the electrostatic force between those two charges is given as 0.1 Newton. So the force exerted, electrostatic force experienced by the charges of this magnitude 0.2 microcoulomb and 0.45 microcoulomb, the force is 0.1 Newton. If that is the case, what is the distance of separation between these two charges? That is the one it is asked. This equation is one applicable for all of them. K, F is equal to K into Q1 Q2 by R square. Substitute for all the given and remaining R square, you solve for it. Here F is given the same equation. Substitute for all of them given for them, given the values. F is equal to 0.1. And K value it is not given, it must be known. 9 into 10 to the power of 9 in SI units. If you write this in SI units, other also should be in SI. Keep it in mind, all of them should be in the one system of unit. Should not write in different system of units. So all of them should be in SI units. So value of Q1 is equal to, given as 0.2 microcoulomb. Microcoulomb is not SI, coulomb is SI. What is micro? The prefix 10 to the power of minus 6. So write it as 0.2. Simply don't write it as 0.2. 0.2 into 10 to the power of minus 6 in SI. If it is not in SI, write it in SI. Convert it to SI and put it into the equation. So this is in SI, 0.45 into 10 to the power of minus 6, and R square is supposed to calculate. You solve for R, this is the equation, substitution. Solution is very simple, take this simplified. So with this simplification, what is R square is equal to, this goes to denominator, this comes to left hand side. Simplify, we get 9 into 2 into 4.5 numerical values. and these are exponentials of 10. This is exponential of 10 to the power minus 4, of course. So with all these exponents, you simplify, you get 10 to the power minus 4. So this value is 81 into 10 to the power minus 4. R square is equal to 81 into 10 to the power minus 4. I want R. You write it in the square form. That is 81 means 9 square. 10 to the power minus 4 means minus 2 to the power 4. So 9 into 10 to the power minus 2 whole square in square form. Square cancel, R is equal to this. You get the value in SI because the values substituted are in SI. This is the value of R in SI in meter. 0.09 meter is the distance of separation between these two charges which experience a force of 0.1 Newton. This is the way of solving the problem. The second problem is this one. I read the problem. There are two charges in the space Q1, Q2. Both of them are positive charges. Plus 2 microcoulomb. It is plus 4 microcoulomb. The force exerted between these two charges are 20 Newton. That is electrostatic force. If that is the case, what would be the force? That is, what is the force exerted when minus 6 microcoulomb of charge is added to each of them? Is added to each of this. What is the next force? For these charges, this is the force. What is the force when you add this charge, that is minus charge, to this as well as this? That is the problem. Solution. Write the equation, same equation. So for this equation, write the data and see what you get. Here 2 F is equal to K. So K and R value is not given. It is understood same for both the data. K by R square. What is Q1? This 2. What is Q2? 4. Into 10 to the power of minus 6, 10 to the power of minus 12. That is in SI units. The value of force in Newton is 20. That is, force is equal to 20. So this we get. That is, from this equation we get K by R. That is, the equation reduced to K by R square is equal to, take it to, that is right hand side, left hand side, K by R square is equal to, you get this value. That is, when you take it to left hand side, 10 to the power of plus, that is simplify, you get 5 by 2 into 10 to the power of 12. K by R square. When you take this to left hand side, all of them into one side, you get this value. So keep it as equation 1. Equation is reduced to this form for this data. What is asked? What is F when you add this to both? So when you add minus 6 microcoulomb to this, what do you get now? That is plus, this 2 is neutralized, remaining is minus 4. It is plus and minus when you add neutralizes. Plus and plus when you add, it increase. Here plus 4 is already there. When you add this 4 is neutralized, remaining is minus 2. This plus this, minus 2. This plus this, minus 4. Now what is Q1 for the next one? The force to be calculated. The same. This is same for both the data, K by R square. What is Q1? This is minus 4. What is Q2? Minus 2. With the addition of this. And 10 to the power of minus 6, 10 to the power of minus 6, that is 10 to the power of minus 12. Simplify. This is the one. Now this is the one you have to calculate. This is the one we did not know. It is substitute for this. That is, put this equation. This K by R square is equal to this into this equation. So k by r square is 5 by 2 into 10 to the power of 12. This is the one simplified 4 into 2 minus into minus plus 8 into 10 to the power of minus 12. This get cancelled. Remaining is this into this divided by 20 force Newton. Look at this. What is the force exerted is 20 only with these charges. When you add this, you get the same force. That is only change now. Plus 2 plus 4 changes into minus 4 minus 2, same magnitude. The force will remain same. Only a change of what is the charge, the sign of charges. That is plus becomes minus and interchange the magnitude of this. The same force. So this is the value or solution for this problem. So next problem, the data is here. I will read the problem. There are two charges given. Q1 is Q2. Both charges have same magnitude. Q same sign plus plus. In the space, the force experienced between these two charges are 1 Newton. The electrostatic force between these two charges is 1 Newton. You are supposed to calculate what is that? What is the force? Asking when 60% of the charge it transferred from Q1 to Q2. The same charges. If you transfer 60% of the magnitude of this charge into this, what is the force exerted between those two resulting charges? So that is the problem. Use the same equation for this data. Substitute for what is given. Force is equal to 1 Newton. K. What is Q1? Q. What is Q2? Q. Q into Q by r square. So again here K by r square is equal to 1 by. This equation is reduced to K by r square is equal to 1 by Q square. When we simplify this for this data. What is asked for? And 60% is transferred. What is meant by 60%? 60 by 100. 60% means 60 by 100. What is 60 by 100? 3 by 5. Simplify 3 by 5. That is 60% of charge. It means 3 by 5 amount of charge is transferred from this point to this point. That is 3 by 5 Q is charged. That is transferred. If this amount is transferred, the remaining amount, remaining charge on this is this minus this. That is less by this. What is the charge at this point? More by this. 3 by 5 Q. So the Q1 is this, Q2 is this. They are different. What is that? The values we have. You have to calculate what is the force exerted. What is the electrostatic force exerted if this is the case? F is equal to same equation. You will substitute for Q1 and Q2. This is one, this is one. First is simplify this. Taking LCM, simplify. This into this is equal to, taking LCM, simplify. This is 2Q by 5. This is 8Q by 5. And this, what is that? K by R square, already you have known, 1 by Q square. So this is the equation you have to solve for F. Substitute for K by R square, that is 1 by Q square. The equation 1 and equation 3 into 2. This and this into this. Equation 1 and equation 3 into equation 2. So this is 1 by Q square. And this is what you have simplified. Then simplify Q cancel. Q square by Q square cancels. And this into this divided by this 16 by 25. Look at that. electrostatic force experienced by these two charges, of course, the distance remains same, is 1 Newton. If this happens, what is the force? The force is 16 by 25 Newton. And the distance of separation remains same in both the cases. This is a problem and the answer is this. And the next problem is I'll read that problem. There is a Q amount of charge. Only one charge is there, one point charge is there in this space. This charge is split into, that is broken into two pieces. That is charge of Q and the remaining charge is Q minus Q. This is charge remaining. If you remove Q, remaining is Q minus Q, small q. So this is broken into two pieces of this magnitude and this magnitude. After that, what is that? The force is exerted, that is electrostatic force. What is asked? What is the relationship between this and this? That is Q and Q. When they are separated by some distance or with a maximum amount of electrostatic force, have maximum coulomb of repulsion. So what is the value of Q and what is the value of Q? After the separation, which experiences maximum, that is electrostatic force. That is the repulsion of force, because both of them are plus. That is the one, the data, the problem what I read. Use the Coulomb's equation, same equation. Right, that is what is Q1, Q2, substitute for this Q1, Q2 and see what you get. This is Q1, this is Q2. R square, which you don't know. This is called as equation 1. Now for this type of problem, we see the differential form of this equation. Why I am taking differential form of this equation? Because we know that is F and Q are variables. What is F? Electrostatic force. Q is the magnitude of charge. Of course, one of the charges. If this increases, this also increases. That is, in the differential form, dF by dQ is equal to positive. The rate of change of force, electrostatic force with Q, it is the increases positive charge. With the increase of charge, electrostatic force increases. That is our differential form. So, in the what is that? Because of this variability, what is that? We can write it as in the differential form as well. Because of this, what is that? We can convert this into what is the differential equation. How do you convert differential equation? Differentiate this equation with respect to Q, function of Q. That is, differentiate F with respect to Q, dF by Q. K by R square is constant. K by R square is constant, and this is a product of two functions. Q into Q minus Q. So differentiation of the product is first function into differentiation of second function. Here Q is a constant, variable is Q. That is initial, what you have taken, afterwards it is broken into pieces. That is constant Q. Constant into differentiation of minus Q is minus 1. 0 minus 1. Plus second function into differentiation of the first function. 1, Q minus 1. Now dF by dQ is variable. Different value, different forces. Now what is asked? At what state maximum forces, maximum electrostatic force arises between those two charges? What is the condition? Maximum force means when the force, there is different values, different force. But at one particular value of Q, there is a maximum force for all the values. Remaining values are small forces are. So one value, there is a specific value, one particular value of Q, that is a maximum force. It is called specific. Usually specific is called as constant. If F is equal to F max, it is a constant. So this equation becomes 0. That is, differentiation of constant is 0 at F equals maximum. So write the equation for F is equal to maximum. The differential equation for F is equal to maximum. This equation for F equals maximum. This becomes 0 because differentiation of any constant is 0. So it has reduced this equation. This you rewrite this as what is that? 0 is equal to, if you take this to left hand side, 0 is equal to Q minus. So that is Q is equal to PQ or Q is equal to Q by 2. That is the relationship between this charge and this charge. Initially I have taken this charge, it is broken into two pieces. When the electrostatic force is maximum, when the this charge is split into what is the charges of equal magnitude. When this charge split into, that is Q is equal to Q by 2 means two charges of same, that is Q by 2, Q by 2, that is Q by 2, Q by 2. So when you split this into two charges of equal magnitude, then only we see that maximum forces. If it is split into what is that unequal charges, any values of unequal charges, that force is always less than this force. That is the idea. That is the problem of this. So we need to understand the concept. What is the important is we go for what is the differential form of the equation, then you only can solve this equation like this. Concept. The concept of differentiation finds applications in problems like this. And the last problem is, that is a triangle is there, equiangular, that is equal length, equiangular equal sides. All angles are equal, all sides are equal. The scalar is triangle. What is the problem actually? The problem is at the vertices of the triangle, three charges are kept, and the magnitude of all the charges remains same. Q, Q, Q. The difference here, you have plus Q, you have kept here plus Q, here minus Q. This is a triangle. This at this point, there are 3 points in the space, and all the 3 points are the vertices of this. What is that? The triangle, scalar triangle. 60 degrees. All angles are equal. All sides are equal. That is a problem. At this point, what is asked? What is the force experienced, net electrostatic force experienced at this point, at the C, that is on this charge? Here there are 2 charges, there are not 2 charges, totally 3 charges in the space. So this will take the principle of superposition. We call that principle of superposition is any net force at any point, net force at any point, if there are multiple charges, it is a vector sum of all the forces. That is, at this point, there are 2 electrostatic forces due to this as well as due to this. So the net charge, the net force at this point is, what is that? Let us write this. What is the force experienced at this? Redraw this same triangle, but they are not mentioned. It is understood. Q is there, Q is there, Q is there. A is the side. What are the forces exerted at this point? There are 2 electrostatic forces exerted at this point. That is on this charge. That is, one is electrostatic repulsion. That is away. This is the direction of the force. Other is electrostatic attraction, because minus Q plus Q. Plus Q plus Q electrostatic repulsion. That is the direction of the electrostatic force. This is the direction of the electrostatic force. That is, let us call this as F1, F2. There are 2 forces acting at this point. The net force is vector sum of these 2 forces. That is F1 plus F2. What is vector sum of these two forces? The vector sum of these two forces, the force is what is that moving away from this point, is away from this one. This is the direction of this is a vector away from this point, vector away from this point. If that is the case, the sum of vector is the one, what is that? The equation already we know that sum of these two vectors, the equation or formula, standard formula is this. It called also called resultant vector. The net force is in this direction. This is called resultant force, or vector sum of these two is Fr. The given by the formula root of square of this plus square of this plus 2 into this cos theta. What is cos theta? Angle between these two vectors. What is the angle between these two vectors? If this is 60, I told you all angles are 60, and this is totally 180 and 180. So 180 minus 60 is 120. The angle between these two is 120. So theta is 120. You know that 120 is angle, and let us calculate what is F1 and F2 using Coulomb's law. That is, what is the force? What is this force? What is this force during what is between because of these two charges? Because of these two charges, and the separation of these two charges is A. Separation of these two charges is again A. Apply Coulomb's law. F1 is equal to, that is the one, electrostatic force at this point between these two charges, that is Q into Q, K Q square by A, Q into Q by A square, Coulomb's constant. What is it electron? That is repulsion, this is the attraction. Then again Q and Q, there is minus, can take it up, product no, only Q and Q magnitude. Again K into Q square by A square. F1 is equal to F2. F1 equals F2, it is same as F, let us write it as F. These two forces are same. What is the resultant of this force? Using this equation or formula, it has come from the law of parallelogram. That is F1. F1, F2 are same. That is F square, that is F into F, F square. This is 2F square, that is 2F square cos theta, cos 120. Theta is 120, angle between these two vectors. Simplify taking LCM 1 minus. Cos 120 is minus 1 by 2. Cos 120 is minus 1 by 2. That is 1 minus 2. That is 1 minus of 1 by 2 is again 1 by 2. 1 by 2 into 2 cancel, F square remains. So root of F square is F. So finally, after all this simplification, what is Fr? Using this formula, Fr is equal to F. That is F. So what is F? K Q square by A square. What is F? K Q square by A square. The net force at this point due to these two charges is K Q square by A square. That is the one you get. And the problem is further proceeded here. Find the force at C. If the charge is 100 microcoulomb, that is this charge is same, 100 microcoulomb, and A is 1 centimeter. Distance of separation, that is a sides 1 centimeter. That is F. What is the resultant force? F is equal to this 1. The resultant force at this point, that is the vector sum of these two forces using law of what is the principle of superposition is F only. F is equal to Q K Q square by A square. Substitute for Q. Q square means 100 into 10 to the power minus 6 whole square, and A square in SI 10 to the power minus 2 meter whole square. Simplify because all this thing exponential of tens, and tens only 9 into 10 to the power 9 into 10 to the power 5 Newton force. Is clear? The answer is this for this data. That means at every corner of this triangle, at the every vertices of this triangle, at equal sides, the net that is separated at a distance of 1 centimeter each side, that is distance, the net electrostatic force acting at this point due to these two charges is 9 into 10 to the power of 5 Newton. That is the solution we arrive at like this. Arrive at. So this is the way of solving this time. It is based on, that is again the Coulomb's law, it is a principle of superposition based on. Like this you have different diagrams aligned in multiple charges. You can draw the diagram, a required diagram, and you have to calculate what is the net charge at this point. So this is the one we have solved the problems like this. Keeping in mind only it is based on this equation of the set of problems.